how many different 5-card poker hands are there? Well, this assumes you know how many cards are in a standard deck of cards. So, and by the way, if you forget that there are 52 cards in a standard deck during an exam, just ask me. I'll even write all 52 cards on the board if necessary, if you've never seen what a deck of cards looks like. So how many 5-card poker hands are there? Well, it doesn't matter if it's poker or any game that requires 5 cards. So how many are there? Well, this is taking a deck of 52 cards and choosing how many ways can you choose 5 of them. That's the answer to this. It would have the same answer if you said I have 52 marbles. How many ways can I choose 5 of them? It would be the same answer. Remember what that is? It is the combination of 52 taken 5 at a time. Now, if we were to work it out, we're going to get a big number. Remember what goes on top? 52 factorial goes on top. What goes on the bottom? Well, I know 5 factorial is going to go on the bottom, and the other number is 52 minus 5 factorial. So 52 minus 5 is 47 factorial times 5 factorial. Okay, so now hopefully you know how to cancel this to simplify it as much as possible before we plug it into a calculator, because I want to plug this one into a calculator. Let's say, I'm not going to do this too many more times, but I will this one last time. 52, 51, 50, 49, 48, 47 factorial. Because what I have here on top is just 52 factorial. It's 52, 51, 50, all the way down to 1. But I wrote 52, 51, 50, 49, 48 times, and then the 47 factorial takes it from 47, 46, all the way down to 1. And maybe I will put the, I'm going to write the 5 factorial like 5 times 4 times 3 times 2. And I'm going to leave off the 1 just because it doesn't do anything, doesn't change anything. And then I'm going to put the 40 times 47 factorial on this side so I can easily cancel them. And now, how do we cancel these? Well, one thing we could do is, I like to cancel, I like to say 2 times 5 is 10. I canceled a 10 on the bottom, so now I'm going to cancel a 10 on the top. So I'll cancel the 50, and it'll turn that into a 5, right? 50 over 10 is 5. All right, now let's see, actually, what's 4 times 3? 12. What is 48? 12 times 4. So if I cross out the 12 here in 3 times 4, that's 12. I cancel this out, I divide that by 12, and I get a 4. Now, I remember that this number is something like 2.5 million, but I want to make sure. 52 times 51 times 5 times 49 times 4. Yeah, let's see, it is 2,598,960. So that is a big number. So when you're playing a game of cards where you get 5 cards dealt to you, this is exactly how many different hands you could possibly get. Okay, let's look at something a little easier. The next several are really just about subsets. So how many subsets of size 1 does this set have? Well, that's easy, isn't it? Well, we can figure it out by saying it's the combination of 4 things taken one at a time, right? How many ways can you choose one thing? I could have written this as 4 choose 2, which is the same, 4, choose 1, which is the same as this. You don't need to plug that into the calculator or even use the formula because you got 4 things. How many ways can you choose 1? 4. But just for practice, 4 factorial over 3 factorial, because that's 4 minus 1, times 1 factorial. Well, 4 factorial is 4 times 3 factorial. So the canceling these two leaves me a 4 on top, and that 1 factorial is just a 1 on the bottom. So 4 factorial over 3 factorial is just the number 4. And if we were writing them out, remember, subsets. This is required. You have to have the squiggly bracket. Otherwise, it's not a set. Okay, that's the 4 subsets of size 1. And if all we were asked was how many, well, we could have just plugged it into the formula. Now, this will be interesting, this next one. How many subsets of size 3 do we have here? And your first response might think, well, I'm going to have more than the previous one, but that's not correct. Let's figure out exactly how many. The combination of 4 things taken 3 at a time is 4 factorial over 4 minus 3 is 1 factorial times 3 factorial. Well, look at that. It's exactly the same as what we had up here. The 1 factorial and 3 factorial are switched, but that doesn't matter. You can multiply in any order. So once again, we get 4. That's interesting. And writing them out would be what? I'll do WXY. That's one subset of this that has 3 elements. What's another one? How about WXZ? How about WYZ? And I think that's all of the subsets that have a W in them. We've done everything. We took a W and then we took those two, and those two. So the last one is the one subset that doesn't have W in it. Oops. Comma. X, Y, Z. And I'm going to mention this later, but it's worth noting now. It's not just coincidence that there's 4 here and there's 4 here. Notice, this one single element, when you take 3 of them, you're leaving 1 out. If you leave the W out of this set, it gives you XYZ. So this one kind of corresponds to this. When you leave the X out, you get this set. Maybe I'll put a squiggly under it. So those correspond. The one set X, and this is the set that doesn't have X. And then, I don't know, I'll circle this one. Y, and then that corresponds to this one that does not have a Y. So there's a 1-to-1 correspondence, and then this one is a Z, this one doesn't have a Z. When you choose one thing out of a group of 4, you're leaving 3 of them behind. And that's what we've got over here. When you choose 3 things from a group of 4, you're leaving 1 of them behind. So there's no wonder that there's exactly the same number of subsets with 1 element as with 3 elements. Notice that 3 plus 1 equals 4. Okay, let's look at the next pair. Okay, we're getting a little bigger here. How many subsets of size 2 does this have? This is going to be a little bit tougher. Well, not tough, but just going to take a little extra time. So let's write out the subsets. Let's do all of them that have a V in it first. Remember, we're just choosing 2. So I can go VW, VX, VY, and VZ. That's all of the subsets of size 2 that have a V in it. So now I can just pretend like V is done. So now let's do the ones that start with that have a W. W. I don't have to go back to V because we've already got VW. So V is absolutely done. Now we just need to keep the two sets with these 4 characters. So W, X, W, Y, W, Z. And now we've just got X, Y, and Z to play with. So X, Y, X, Z. That's all of them that have X. And then Y, Z. So you can verify. If you randomly picked a pair here like WY, we've got it right here. VZ, we've got it right here. We have all of the subsets of size 2. Remember, subsets order does not matter. So VW, there will not be a WV because WV would be exactly the same as VW. We're talking combinations or subsets. Okay, so what's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what does that mean? The combination of how many elements do we have? 5. I know I'm going to get 10 because the number of ways you can choose 2 elements out of this group of 5, we counted them up. We wrote them all out and counted 10. Let's use the formula. What goes on top? 5 factorial. What goes on bottom? 3 factorial, 2 factorial. The 3 factorial came from 5 minus 2, and then the 2 just came from this one right here. So let's see. I'm going to write this. Let's see if you can follow what I'm doing here. You agree with that? What I did was, this is 5 factorial is 5, 4, 3, 2, 1, and this is 3 factorial is 3, 2, 1. So I wrote 5 in my mind. I thought 5 factorial is 5 times 4 times 3 factorial. And I canceled the 3 factorials. And then 2 factorial is just 2. 20 over 2, and it's indeed 10. Now, if you remember what we talked about just a few seconds ago, how many subsets of size 3 do you think there are? Well, there are 5 elements, and remember we did 2 in the previous problem. 2 and 3 add up to 5. So that means there's going to be the same number. Combination of 5 things taken 3 at a time, is going to give us the same number. And you'll see why. On top it goes 5 factorial, and then 5 minus 3 factorial is 2 factorial. Times 3 factorial. Notice this is exactly the same as that. So I know we're going to get a 10. And I'll go ahead and write them out. I don't want to do this too many more times, but VWX, VWY, and VWZ. All right, now I'm going to go to, from VW, I'm going to go to VX, VXY, VXZ. Now I'm going to do VYZ. I've done all of them that have a V in it. So now I can pretend like that doesn't exist, and I'm going to do WXY, WXY, WXZ, and WYZ. So now I just did all the remaining ones that have a W in them. So there's only 3 elements left that I need to worry about, so XYZ. And once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the correspondence between this and number 9 and number 10, VW, if out of these 5 sets you choose VW, what would you be leaving? You would be leaving XYZ. So these two kind of correspond to each other. And likewise, each one of these would correspond to one of them. Okay, let's get ready for the next video.